This is our problem statement. Our aim is to predict the wind energy based on the previous year data set of energy output of wind turbine. We processed on it and we predict the energy output. In this prediction, we face the major issue called weather change. The certain weather change can affect our energy prediction result. This is our problem statement. We made a solution for that. We embedded a weather prediction to the energy prediction of wind turbine. You can see the next 72 hours weather predicted by us, and you can use these to predict the wind energy. This is our technical architecture. This technical architecture consists of our whole project path. The future scopes of wind turbines are offshore wind turbines. It's basically in the sea level. It presents on the sea, not on ground. It is the future scope of wind turbine. Another future scope of wind turbine is highway windmill. By this method, we can gain more energy without need of the separate space for the wind turbines, because it's an embedded in the highways with the lamps. So these can help us to improve and gain more energy from the wind turbines. Our project title is Predicting the Energy Output of Wind Turbine Based on Weather Condition. It is the title from the domain of Applied Data Science. First, we processed on the project objectives, project flow, prerequisites, and prior knowledge and project structure. After we know about it, then we jumped into the ideation phase, and we completed it and uploaded on the GitHub, and also completed project design phase 1, phase 2, and planning phase. These are all the things before the project development. We completed it, and then we processed the project development phase. In project development phase, there are 4 phases named sprint 1, 2, 3, 4. Here you can see the project development sprint 1, 2, 3, 4. We completed the sprints by splitting into 4 sprints. In first sprint 1, data collection and data pre-processing, and we done and upload it on the GitHub. Then we process the model building. For model building, we choose the model named random forest regression, and then we process on the API integration for weather prediction. We made an API key using the Open Weather Map. It provides a free API key for the predicting the weather conditions. And then we jumped into the application building. The sprint 2 is model building. The sprint 3 is application building. The application building consists of 3 phases. Build the Python Flask app. This is the Python Flask app, and we made and uploaded on the GitHub, and also build 2 HTML pages for predicting the energy, and we also tested it. And then we trained the model on the IBM cloud. Here you can see the IBM cloud. After the application building, we trained the model on IBM. Here you can see the IBM cloud. We are using the Watson Studio to model building. Here is the our model building using the IBM Watson Studio. Before we train the model on IBM, we are making a model building using the Jupyter notebook via Anaconda software. This is our model building. Before we train the model on IBM, we need to build our model. In this, we use the random forest regression for the model building. I will show you the random forest model. Here you can see the model building using the random forest regression for model building, and we also evaluate the metrics of the model, and then we save the model. After saving the model, we jumped into the IBM Watson Studio for the model training, and also we done the model training. Here you can see the deployment over here. You can see the deployed model coding here. If you want to see the deployment, you can go to the IBM Watson Studio. Here you can see the deployments here. This is the latest deployment I made, wind power prediction, and I open it. It will be redirect to the another page. You can see the deployment over there. Here you can see the deployment named wind energy prediction. This is the deployment we made. You can see the deployment by clicking the wind energy prediction. You can see the properties of the deployment. Here it is the Python code. We are using the Python code for integrating the Flask app before we seen in the project development phase sprint 3 Flask app. You can see it right here. This is the application building. First of all, we build the Python Flask app. Now we will see the testing of our app. Here you can see our application. This is our index page. This is the first page of our app web application, and this is the predictive page. Here you can see the city selection and weather predictions here over. This is the application without the integration of the IBM cloud, and then we build the application for the IBM cloud server integration. If you click on the run Python file, you can see the output over here. It will load. It will take some time. After the completion of the running of the app.py, you can see the local HTTP link. You can see the link over here. If you can copy, you can paste it over here. After pasting the link, click enter. You will be redirected to this page. Once you click the button named click here to predict energy, you will be redirected to the another page named predict, and here you need to select your city to predict the weather conditions. In case I select Chennai to predict the weather conditions, if I click this button, the weather are shown here. Here there is the weather of the Chennai. The wind speed is 5.54. For example, I give the theoretical power for 300 and the wind speed is 5.54, and I click the predict button. It will show the predicted energy output. Here you can see the energy is predicted 297.59 kilowatt per hour. This is our web application using the saved model of our model building. You can also use the web app by using the IBM cloud integration. This is our web application built by us, and it is using the response scoring of IBM Cloud. In here, there is no need of saved file for the model building. So I put the command line argument hash to disable this line and these two lines also. These two lines also. Then we need to run this file also. Click here to run Python file. It will show the output over here. Here you can see the link. You can copy this link and paste it on any browser you use. This time I use the Chrome to show you the result. Before we see the result of Flask app, now we see the result of Flask app integration with the IBM Cloud. I paste the link over here. After pasting, I click enter. Once you click enter, you will be redirect to this page. You click here to predict energy. You need to click this button. After clicking this, you will be redirected to the next page named predict. Here you can select the city. Before I selected Chennai, now I selected Ariyalur to see the weather condition. After selecting the city, I click check weather condition. Here you can see the current weather conditions of the city. Now 500 for theoretical power. The wind speed of Ariyalur is currently 10.296. So I give this 10.296. If I give this, what will be the predicted energy? Shall we check? I click the predict button to predict the energy. Here you can see the predicted energy is 383.42 kilowatt per hour. This is our predicted energy by the model we trained before. By this way, you can predict the energy output of wind turbine by the weather conditions. You can also add some cities to it. Our Flask app will be accessed by anyone from everywhere. So you can download the code from the GitHub. The links are provided in the description. So you can download it and test it over everywhere. Thank you.